Hello, this is your instructor Dr. Vasudevarao Aravind. In this physics class, we try to study the laws of nature and how the universe works. We want to make machines that work and build rockets that fly. For this to happen in the real world, we use different forms of energy. Some examples are heat energy to keep us warm, metabolic energy to do some physical work, and light energy to help us light the world. Here, in this video, we will try to understand three terms: energy, work, and power. Let us talk about the relationship between energy and work. Energy is relevant to us because we need energy to do some work. We need energy because we need to get something done. For example, we may need to move something from here to there or go from city 1 to some other city 2. The amount of energy we have determines how much work we can do. Greater the energy, greater the work. When I say work, it does not necessarily mean physical work. We use work derived from energy to heat our homes, for welding and machinery, to operate heavy machines, to light up our living spaces, and so on. In order to use energy effectively, it is important to quantify and measure energy and work. If you have $10 in your wallet, you cannot buy stuff that costs more than $10 at a store. Similarly, if you have a limited supply of energy, there is only so much work we can do. So, how do we quantify energy? Energy and work are both measured in units of joules. To give us a perspective, a tennis ball moving at a speed of about 14 miles an hour has an energy of about 1 joule. Other commonly used ways of measuring energy or work is a calorie or a kilocalorie. 1 calorie with a small c is the amount of heat energy required to raise the temperature of 1 gram of water by 1 degree Celsius. 1 kilocalorie is equal to 1000 calories. The other one you will hear people using often is the British thermal unit. This is more or less used when you talk about energy in the form of heat as you receive from a company and so on. So 1 BTU, the British thermal unit, is the amount of energy required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. So the joule, the calorie, and BTU are just different ways of measuring energy. So there must be a way to convert from one unit to another. The unit conversions are given here. 1 calorie is equal to 4.184 joules. 1 BTU is equal to 1055 joules. So also you can do the reverse conversion. 1 joule is 0.000948 BTU, or 9.48 times 10 to the negative 4 BTU, and 1 joule is 0.24 calories. The term power is used to express the rate at which energy is used. So power is defined as the ratio of energy divided by the time. Or in other words, it can also be expressed as the rate at which a system is doing work. So power can also be expressed as work divided by time taken to do that much work. So if energy or work is measured in joules and the time during which the energy is expended is measured in seconds, then the power extracted from the system is expressed in units of watts. For example, if you extracted 1 joule of energy or work from a system every 1 second, then you are extracting power at the rate of 1 watt. Notice that since power can be expressed as the rate at which energy is consumed or the rate at which work is done, the relationship can be equivalently stated as energy or work is equal to power multiplied by the time. This gives us a new unit for measuring energy. Suppose an equipment that is rated for 1 kilowatt consumes an electrical energy for 1 hour, then we can calculate the energy consumed. So energy is equal to power multiplied by the time. So 1 kilowatt times 1 hour, which is 1 kilowatt hour. So kilowatt hour is another unit for measuring energy.